Today we will talk about building blocks of NMR, how to solve an NMR spectrum. There are five building blocks of NMR interpretation of any spectrum. Chemical shift identifies environment. Integration tells us the number of protons. Splitting find neighbors. N plus one rule are used. J coupling measures interactions and functional group range, recognizing common peaks. Lux 1 chemical shift. It tells us the position of a peak on the x-axis in ppm and also electronic environment of a proton. Either they are shielding or deshielding. Upfield range. Block 1 chemical shift. It tells us the position of a peak on the x-axis in ppm and also electronic environment of a proton that are shielding or deshielding. Upfield right side. Lower delta shows more shielded proton like alkane. Downfield left side. Higher delta tells more deshielded protons like aldehyde. 9 to 10 ppm. Example, TMS appeared at 0 ppm as a reference. Block 2 integration. It tells us the peak area and number of protons. It tells us the area under the peak and number of proton contributing to that signal. Any signals? Example, a triplet with integration 3 methyl group. Here is a quartet with integration 2. Here's a methylene group. Block 2 splitting tells us the multiplicity and plus one rule are used. Why do peaks split? Neighboring proton cause splitting. According to n plus 1 rule, singlet appeared when there is no neighbors proton are available, doublet one neighbor proton, triplet two neighbors protons, quartet three neighbor protons. A quartet plus triplet ethoxy groups. Here is a quartet and this one is a triplet of ethoxy group. Block 4 J coupling. It tells us the distance between split peak in hertz measures connectivity and dihedral angles. Geminal cis and trans alkene protons in geminal J2 to 3. Here's a geminal coupling in a trans J15 to 18. Here's in a trans 15 to 18 hertz and in a cis 10 to 15. Block 5 Functional group chemical shifts. Quick reference for chemical shift values. 0 to 2 ppm alkanes appears, methyl or methylene. 3 to 5 ppm oxygen bonded proton, methoxy or methylene oxy groups. 5 to 6 ppm alkene protons, 6 to 8 ppm aromatic proton, and 9 to 12 ppm aldehyde and carboxylic acid. Here's a appeared carboxylic acid, aldehyde, aromatic alkenes, and here's a alkyl group. We will discuss the proton NMR analysis of N4-ethoxyphenyl benzene sulfonamide. Here is a compound. Actually, this compound is prepared in the laboratory by the reaction of benzene sulfonyl chloride with 4-ethoxyaniline. Here's the actual spectrum of sulfonamide. Right side tells us on which the spectrum was taken. It was taken at 400 megahertz and the solvent was used CdCl3. Chemical shift actually tells us the position of peaks on the x-axis. On the right side actually tells us the shielded protons and the left side tells us deshielded protons. Integration shows the peak and number of protons and J value tells us the coupling and peak splitting. Further, we will discuss aromatic proton, which are a paired 7.6 to 6.7 ppm para-substituted benzene ethoxyphenyl group. This one is the para-substituted para-ethoxyphenyl groups. Due to symmetry of the molecules, uh, signals appear 6.93 as a doublet, J value 8.8 Hertz, 2 proton H2 prime and H6 prime. Here's the 2 protons, and the J value calculated here. Larger value subtract from a lower value and multiply with the NMR was taken at 4 megahertz. So value is 8.8 hertz. Tells us that these two protons are coupled with these two protons. These are the ortho coupling. 6.76 another doublet was appeared. J value 8.8 hertz, two proton H3 and H5 prime. Here's the H3 and H5 prime. Benzene sulfonyl ring, one doublet and two triplet, five protons slightly deshielded. Due to sulfonyl group, the protons are deshielded, appeared at 7.68 at doublet, G value 7.2 Hertz, 2 proton H2 and H6. Here's a 2 proton H2 and H6. Due to orthocouplings, appear J value at 7.2 Hertz. Another triplet is appeared 7.51, J value 7.2 Hertz, 1 proton H4, this one orthocoupled these two proton and showed a triplet, and other triplet appeared 7.40, J value 7.2 Hertz, 2 proton H3 and H5, H3 and H5. These two proton coupled with the 6 and 4 proton and appeared a triplet at 7.40. Ethoxy group appeared at 3.97 and 1.36 ppm. Its methylene oxy group appeared as a quartet due to coupling with methyl group, and the methyl group appeared as a triplet due to coupling with the methylene. It's a 3.95 quartet appeared. Here is a quartet appeared. Uh, J value 6.8 hertz, 2 proton, H7. Here is a methylene proton, and 1.36 a triplet appeared. J value 6.8 hertz, 3 proton H8. Here's a H8. Here's a triplet appeared of the methyl group. Overall, we observe aromatic doublet, triplet, and ethoxy peak in this spectrum. Further, how to write down in a thesis. Firstly, write down the name of the compound. Next, the proton NMR and the solvent in which the spectrum was taken, on which megahertz delta in ppm, and start from higher value, mean chemical shift, to a lower chemical shift. And here's the structure and the name of the compound.